Let's talk about converting. There are two different ways to convert. So the first way is if you think about the fact that logs and exponents are. So background information, log base whatever of x answers your question base to what power is equal to x. So base to what gives me that x value here. So the background information in this idea is that if you have something like log base b of x equals some y value here, you can rewrite it as your base to what power y would give you that x. Or think through the fact that logs and exponents are inverses, and inverses switch their x and y values. So if it's written in log format, the x is with the base. If it's written in exponent format, you have to switch it, and the y is written with the base, or whatever these values happen to be when you do your real problem. In a similar idea, if you had base b raised to the x power equals y and you wanted to convert this to a logarithm, well, you have to write it with log format and it has to have the same base, but you switch your x and y's. So instead of the x being with the base, it goes to the other side and y comes over here as my logarithm. So this method here, you're just switching your x and y's, and then make sure you pay attention and write it in the correct format, exponents versus logs. Let's do some examples. Okay, so if I asked you to convert, if it's an exponent form, write it as a log. If it's as in a logarithm form, write it as an exponent. So here, if I was going to convert problem 1, the base is 2, so I need to convert it to a log, so I need a 2 there. And the 6 and the x, they're my inputs, my x and y's in this case, need to switch sides of the equal sign. So the x goes away from the 2 and the 6 comes with the 2. Now it's converted and I'm done. Same idea in problem B. I'm going to write it straight underneath. This would be log base 9. It has to have the exact same base. And the x and y's switch sides of the equal sign. So the 5x plus 1, the whole thing moves over to the other side of the equal sign, and the 21 comes over here with the 9. Same idea here, log base e is just natural log. Ooh, I don't need a 1 there. And the x and y switch sides of the equal sign. So the x squared goes away from your base and the 1 comes with it. Use correct notation as natural log. All right, same idea if I start with a logarithm and move to an exponential form. My base here is a 4. And then my x and y switch sides of the equal sign. So the 3x goes to the other side and the 1 becomes my exponent. And last, this is log of 9x plus 2 equals 5. This is a common log. Remember, that's an implied 10 there. So my base is 10, and the x and y switch sides of the equal sign. So the whole 9x plus 2 moves to the other side, and 5 becomes your exponent. If you don't like that method, I like that just fine, except that this is a little more helpful for us to convert using this method when we are solving equations. So I would suggest you maybe focus on this method instead of the other one, but if this method is too much for you, confusing, go back to the other way. Okay, so how to convert method 2. This uses another property of logs that we don't talk about a ton, but if you have a log and inside your logarithm is an exponent, if they have the same bases, then these two cancel each other out, and it's just whatever number you have here as your exponent, or whatever expression you have there, is your answer. Same idea if you have an exponent, and in your exponent is a logarithm. If these two bases are the same, and they could be different, on your homework, so you have to be careful. If these two bases are the same, they cancel each other out, and you're just left with whatever was in your parentheses here. It's no longer in the exponent spot, it's just a normal expression. Okay, so why do we do that? If x equals y, then a to the x equals a to the y, and log base a of x equals log base a of y. So we're going to use that fact and these two properties up here to do those same conversions. Okay, so if we do that, we have 2 to the x power equals 6. Let's put log base 2's in front of both sides of the equation. Because if x equals y, log base a of x equals log base a of y. This property. All right, so I can put log base 2's in front of them, but why would I do that? Because if I have a mixture of logs and exponents and the bases are the same, I can cancel those out and I'm just left with this x right here. So cancel. On the right side, nothing cancels out, so I'm going to leave it as log base 2 of 6. Done. Same idea for the part B. My base is a 9, so let's put log base 9's in front of both sides. Why would I do that? Because here log base 9 and base 9 to the 5x plus 1 power cancel. This 5x plus 1 just becomes a normal part of the equation. And on the right-hand side, log base 9 of 21 stays as is. Same idea for part C. Base is e, so log base e is natural log. If I put a natural log in front of both sides, natural log base e and e to an exponent cancel out. I'm left with just the x squareds, and the right side stays as is. In the bottom, instead of putting logs in front of both sides, I want to put exponent bases. If x equals y, a to the x equals a to the y. So same idea here. Since this logarithm equals 1, I can make this 4 raised to the log power equals 4 to the 1 power. Then on the left, my base 4 for my exponent and my log base 4 cancel. This is just a normal 3x, and on the right, it stays 4 to the 1 power. Same idea for the last example. Common log has an implied base of 10, so I can make this 10 raised to the log power equals 10 raised to the 5 power, 10, and log base 10 cancel, so 9x plus 2 equals 10 to the 5th. And you'll see we got the exact same answers we got before. It doesn't matter that they're flipped. So you just need to choose which method you prefer. I think this method over here, the second one we did, would help you more when we're doing solving logarithms next class.